here we are testing a claim about a mean. So we are done with the what? The proportion. So the proportion is always once, then you are done. But the mean is whether the population proportion is known or not known. Or let me say whether the standard deviation is known or not what? Known. But you know the difference already, that this one is the population proportion and the S is the sample what? Proportion. I said proportion. Sorry. So this one is the population. Yeah, is the population standard deviation. This is the population standard deviation. And this one is the sample standard deviation. Alright, so let's continue. So when the population standard deviation is known, the requirement is that random sample is always the same thing. Now the standard deviation is known, and your n should be greater than 30, or population is normally distributed. So you see that your n will be greater than what? 30. So this always, when your population standard deviation is known, it talks about what? A large sample. It talks about what? A large sample, and you know this already from your previous things. Alright. And the test statistics we use here is this. The test statistics is not the same as the one that we did on the proportion part. Because here, you see in the question, it's not dealing with anything about percentage. The mean question don't deal with anything about percentage. So how are you going to even get the point estimate, which is the p-hat, and the success? No. This one don't deal with any success and failure. This talks about the point estimate of the mean. This is the point estimate of the mean, and this is the mean itself. Alright. And that is that. So let's look at a question and see how we are going to come out with the things that we need to go on. Alright. So first of all, we come out with the claim. The claim. The first one, the claim. So what is going to be the claim? So here it's not going to be P, here it's going to be the mean. Alright. So the claim, let's see the claim. T and T's. This is representing anything, right? You sampled 465 of the sample. T and T's. You sample 465 of the sample and have a mean of 0.8635. So that means that this is the one, the mean. This is the one, the mean. So you know that first of all, that is your mean. So you put it somewhere. The population standard deviation. I hope you can see that. Population standard deviation. That will let you know the test statistics you are going for. Alright. The population standard deviation. And also you can see that your n is greater than what? 30. Let's move on. Yes, so that is the population standard deviation. Tell the claim that the mean weight is greater than, this is what I'm looking for, because that's what we use to state the claim. So tell the claim that the mean weight is greater. So that means the claim is that this is greater than what? The mean. And the mean is what? This is not the mean. Oh, sorry. So this is the mean, right? This is the mean. So it's greater than this. So that means that it's greater than 0.8535. Let me explain something to you. We have the X bar and we have this. This is the population standard deviation. And this one is the point estimate for the mean, right? So, what the person, alright, yeah. So, this side too. So this is the mean. So when the person is saying that the mean of this is the point estimate. That's the point estimate for the mean. So this one, what will come here is what you are having here. You see, both of them is gram. But you can see that this is where the claim is. And where the claim is is where we use to write our claim. So don't be thinking that this is what will come here. I hope it's clear. Alright. So the opposite. So the opposite is that the mean will be less than or equal to 0.8535. Then the second stage is to state your null hypothesis. So your null hypothesis is where the equal to sign is 0.8535. And the alternate hypothesis is where this one will maintain 0.8535. Alright. Good. So that's where the claim is. That's where the claim is. Alright. So now the third stage. The third stage is to identify your alpha level. What alpha level were we giving? Oh, use alpha of 0.01. So our alpha level here is 0.01. Alright. Then the fourth stage, that is where we go and calculate for our test statistics. Test statistics. So let's go and calculate for our test statistics. So we know that the fourth is a test and that is is equal to x bar minus the population standard deviation. Then we have the mean. Alright, so what will be the x bar? Alright, so now the x bar is going to is the one that you were given, that's the mean. So that is 0.86. So refer to the question 635. That is the mean. Alright. And okay, so and this one. So this is going to be the point estimate. Let me put in that for point estimate for the mean. The point estimate for the mean. And the mean is where the claim is, right? Where the claim is. And this is the claim. So that is 0.8. So they are random. You can choose ignore. 0.8535. So this mean is always where the claim is. Don't forget, always where the claim is. And the point estimate is where in the question you will hear the mean. The further you hear the mean is for this. Okay. That is the point estimate for the mean. But the question will not tell you point estimate for the mean. Alright. Good. So after this, what we have? Okay. The population standard deviation. That one was given in the question to be 0.0565. Alright. And the n is what? The n is 465. So we come back to do our substitution. So 0.8635 minus the mean, where the claim is 8535. I know the reason why I'm emphasizing on it, where the claim is. So the population standard deviation is 0.0565 over square root of 465. So what this is going to give you is 3.82. So this is going to give us 3.82. So this is the fourth stage. Then we move to the fifth stage. You know already that the fifth stage and the sixth stage is where you are going to choose the method to go by, whether the p-value method or the traditional method. So with that one, you know it already, okay? So here, I'm going to use the, which one should I use? The traditional method. You can choose any one that you like. The traditional method. So the traditional method, I'll draw my list here. Then I will check my alternate hypothesis. Was it greater than or less than? Greater than, right? Good. So that means that it's going to be here. So the alpha level of 0.01. I know that my z is going to be 2 points. So read it on your table. You get 2.5 2.575. Alright, that's what you're going to get. Then you come back and check your test statistics. 3.182. So this is your failed to reject rating, and this is your rejection rating. So when you check, 3.82 will fall within somewhere here. It will fall within the rating. So the C stage is that you make your decision that you reject your H naught. You reject your H naught. Then the seventh stage is that you conclude from what you have. So the conclusion is that since you have rejected, that means that you have enough evidence. So there is enough evidence that the mean weight is greater than 0.8535. So just simple. The conclusion is just simple. There is enough evidence that the mean weight is greater than 0.8535 grams, and you are done. Okay, so this is when the standard deviation is known. Let's go to where the standard deviation is not known in this same video. Alright, so testing a claim about a mean, still on the mean. But here, this is when the standard deviation is what? Unknown. But not that the standard deviation is not known. This is the population standard deviation is unknown. Alright. So the requirement is that this one is always the same. So the population standard deviation is not what? Known. So you use the X, which is the what? The sample standard deviation. The sample standard deviation. So in the question, you should be expecting something like sample standard deviation. And also your N is, alright, your N is less than 30, or population is normally what? Distributed. But it doesn't order based on where the N being a small sample. It doesn't order based in it, because once the standard deviation is unknown, the population standard deviation is unknown. Whether this is large or small, you can still go by this. Okay. So here, all that is different from the previous question is that here the test statistics is no more the population standard deviation, but it's going to be what? The sample standard deviation. So let's look at this question. You sample 39. So you see 39 is greater than what? 30. But let's see what it's going to be. Soda cans. The mean volume of soda was 12.11. The mean, hope we know what is coming in here. The mean here doesn't mean is this. No. I have told you already that this is always where the claim is. Is at where the claim is. Always a sample standard deviation. So this is also talking of the small one. There's S. It's not population. It's sample. So whether the N is or the sample size is large, it's still talking about this test statistics. Alright, so don't be confused with that. So don't always base on this to conclude. Okay, of 0.2708. Test that the claim that the mean, so that's where the claim is starting. Test that the claim that the mean volume of soda is exceeding 12 with an alpha level of that is your significant what? Level. Alright, so let's see. Beautiful question. Let's see what is going to be here. Alright, so you start. First the claim. And you know this is about me, right? But the claim starts from here. The claim that the mean volume of soda is exceeding. When something is exceeding, what does it mean? Yes, I told you to go for more nearest meaning words. So exceeding means the same as greater. Greater. So exceeding is the same thing. Exceeding 12. Exceeding 12. Alright. Then the opposite. The opposite will be less than or equal to 12. So where the equal to sign is, that's where the alternate hypothesis will be. So the null hypothesis will be, so this one is going to be equal to 12. Then this is going to be greater than 12. Alright, so that is that. The third stage to identify your alpha is 0.01. Beautiful. Alright. The fourth stage is for us to, I don't want to clean this. The fourth stage is for us to identify our S bar, our sample standard deviation, and our mean, and also the n. Beautiful. So back to the question. You sample 39. Oh, that means the sample size is 39. The mean volume of soda wash, I have told you already. This mean here is where your point estimate is. So that's the point estimate. So that's the point estimate for the mean. 12.11. That's the point estimate for the mean. Don't confuse yourself. Always there with X sample standard deviation. That's telling you are using the what? The sample standard deviation formula. Alright. So the sample standard deviation is 0.2708. And this guy is always where the claim is. Test that the claim that the mean volume of soda is exceeding 12. So that 12 is here. Simple. Or you can just check here. Go to 12. You go your way. Don't go and confuse yourself. Alright. So now from here, you've got your formula. You go your way. Alright. So now that you have your values, since we are dealing with the t-text here or the t-distribution. So we are not more going to code, since we are using this, we are not more going to code that the sample population, sorry, the sample standard deviation. We are not more going to code the z again. Okay, so you just do your substitution. S bar is 12.11 minus 12. All this over 0.27 square root of 89. So the result is going to be 2.544. Alright, so when you get to this, then this is your test work statistics. Then you go to the fifth stage where you are going to, whether you go by the traditional or you go by the p-value, but let's go by the traditional. So you want to go by the traditional. Alright, sorry. If you want to go by the traditional, then we have to know that we will draw our alright, so the traditional, we have from the question, it is what? The mu is greater than, that is the alternate what? Hypothesis. So it's the right heel test. Right heel test. Alright. And the upper level. We have the upper level to what? 0.0. Alright, so that's what we have. Good. So now we use that to identify our what? Our critical value. So this is going to be the critical value. So when you know how to do this on the table, you are going to get 2.429. Alright, 2.429. Then you use this test statistics to see where it will fall between. You see that this one will fall between the rejection rate. So that means that we will reject what? The H0. So when you reject the H0, it means that you are accepting the what? The H1, that's the alternative what? Hypothesis. Then you write your interpretation. Now you are rejecting, so what is your interpretation? there is enough evidence to what? Support the claim that the mean level of soda is greater than what? 12. Just like that. And you go your way. So that's going to be your interpretation. So that's all. But you try this for me. What you are going to try is that you are going to maintain the same question, but where it's saying is greater, make it not equal. Use the same question, but make it what? Not equal. Not equal. Alright. So everything is going to be the same, but just that when you get to your traditional method, that is where you have to be careful with it. Alright? Good. So I hope you know where this is coming from. Oh, let me explain it to you well, okay? I hope you have your T distribution. Take your T distribution, let me help you out. This is not, you are not going to read this on the normal distribution. No. Know that this is T is equal to. So this is what? The T distribution. Because we are using we are not using the population standard deviation, and we are using the sample standard deviation. So what you are going to do is that you check for, I'm guiding you how to get this. You have to calculate for degree of freedom, which is n minus 1. So the n is what? 39 minus 1. So the degree of freedom is what? 38. After getting your degree of freedom to be 38, know that the alpha level giving you is what? 0.01. So you just come to your table. You just come to your table. Oh, the T distribution. Alright. So you just come to your table. I hope you can see the alpha levels there and our degree of freedoms. Alright. So degree of freedom of 38. Degree of freedom of 38. Okay. So now you can see that from 30, degree of freedom of 30, you come to 40. So there is nothing like 38 in there. But we can say that the 38 will not be inside of the 40, but the 38 will be inside of the what? Of the 30. So we are going to use the 30 here as 38. Degree of freedom of what? 38. Then we trace the alpha level, 0.01. Okay, 0.01, here is it. So to the 30, that is 2.45 what? 7. 2.457. 2.457. So that's going to be our degree of freedom. I hope you know how we read it. In the 30, you go from 30 go to 40. So the 38 is inside the what? The 30. Then you trace it here. So when you trace it, you get 2.45 what? 7. 2.457. Alright. So and with this, alright, so now that is our critical value. So with this, when you test, you will see that this one will still fall within the rejection range. So you reject them. Now hypothesis. And that's all. Yeah, so use not equal to, change the question to not equal to, but make it, yeah, that's it. And use it to solve it, okay? Let me guide you here. You are going to get the same thing. You are going to get the same results, right? But in the traditional method here, your z-test, know that it's going to be alpha over 2. Alpha over 2. The alpha level is what? The alpha level is 0.01, right? So when you divide by 2, you get 0.005. 0.005. Alright. So this is 0.005. We are going to determine the 0.005 of a degree of freedom. Degree of freedom of what? 38 to get this. We are not going to use the 0.01 to do it. Alright. So we have on your T distribution, you have 0.005. How are we going to see that? Good. Then you identify your critical value. So a degree of freedom of 38. Since 38 is not in, we based on the what? The 30. Okay. So you trace it. Trace. So that will be 2.750. How if you can see that? 2.750. So here will be z is equal to 2.750. Z equal to negative 2.750. 2.750. Alright, so that's how you are going to do to text it. Then you check the same value. Alright, yeah, the same value. So where would this fall? Where would this fall? This is the rejection rate. Right? This is the rejection rate. So under this, if you have 2.5, you can see that the 2.5 will fall within the what? They fail to reject. They fail to reject. So that's that. Good. You don't understand anything, play back and play back again. Alright.